So far we have considered the normal distribution for finding our confidence intervals. And that's fine if we know the population standard deviation, but usually we don't know sigma, the population standard deviation, and we have to approximate it with S, which is the sample standard deviation. However, there's some problems that we run into. S, the sample standard deviation, might not be a good estimate for the population standard deviation sigma when your sample size is small. And in addition, when the sample size is small, the normal distribution really doesn't give as good a results as we would like. We have to use a different sampling distribution. And the sampling distribution that our sample means follow is something called the t-distribution. Or sometimes you'll see that called the student's t-distribution. So the t-distribution is one that changes with your sample size. So here's a picture so you can kind of get an idea what t-distribution looks like. So the normal distribution is this thin black line. So that's that nice bell-shaped distribution. And then the t-distribution varies with the sample size. So if your sample size is 21, then something called the degrees of freedom, which we'll abbreviate DF, is 1 less than the sample size, and that's 20. So this is this dashed line is the t-distribution for sample size 21. And notice that that is a symmetric distribution, but it's not quite a normal distribution, but it's close. Now, if our sample size is only 5, that's this dotted line. That's the t-distribution for a sample size of 5. So notice that that distribution is shaped quite a bit differently than the normal distribution. It's not a bell-shaped curve. It is symmetric though, but notice it's got more area out here in the tails, which means there's more variation in the t-distribution, and that's generally the case. So t-distribution is symmetric about 0. It's got greater spread, so greater variation than the normal distribution with more probability in the tails. And then as our degrees of freedom, and degrees of freedom is defined to be sample size minus 1, as those increase, the t-distribution gets closer and closer to a normal distribution. So using this new distribution, this t-distribution gives us better results. So in order to use that distribution, we have to be able to find t-values. So before we found z-values that looked like this, we found z.05 with 0.05 area to the right. We want to be able to find t sub 0.05, where again, 0.05 is your right area. And we're using degrees of freedom is 13, which means your sample size is 14. So to do this, you're going to use the inverse t function on your calculator. So here is our t distribution. Okay. And we've got the 50th percentile, the median, is right in the middle along with mean. And that t.05 is going to be the t-value that has 0.05 area to the right there. So if 5% of the area is to the right, that means 95% of the area is to the left. So this t-value, t.05, that is going to equal inverse t, and then you input the left area and your degrees of freedom. So our left area is 0.95, and our degrees of freedom were 13. So let's enter that into the calculator. So we go to the distribution menu, second variables, and inverse t right there, number 4. We put in our left area, which was 0.95, and our degrees of freedom, df, which was 13. Paste it, enter 1.7709, 1.77. So the t-value of 1.77 has 5% of the area to the right and 95% to the left. So So that's going to be the first step in finding confidence intervals using the t-distribution is we have to be able to find t-values.